In this video, we'll continue working on page number 2 on 2D handout. This is page number 2. Question number 3, example number 3. Explain why two triangles are similar. So let's go over 3 similarities for reasonings. Okay, what are they? Angle, angle, right? And then next one, side, side, side. And the third one, side, angle, side. So you have only 3 for the triangle similarity, okay? This is notation for similar. Similarity. You draw up first and then down after that, okay? That is similarity. Congruence, you put equal sign below it. Okay, so that's the notation. So number 3. All right, do you see two triangles? A, B, E. Do you see A, B, E? Okay, small one, and then A, C, D, big one, right? Are they similar to each other? Yes, it is a right triangle, right? All right triangles are similar? No, it is not, right? It is not. I need to check angles, right? Do we have common angles between two triangles? Other than 90 degrees? Yes, where? This angle is common for both triangles, right? So that will be another angle, right? So can I say by AA, two triangles are similar? I triangle similarity postulate AA, two triangles are similar. Right? That's the reasoning, AA. Where did I find another clue? That was hidden, but we can figure it out. That is the common part for two triangles. So when it is complicated looking, because it's overlapped, you can separate them, okay? And think about big and small triangles. Do we have common parts other than the given 90-degree angles? Yes, we have one more. So we can say AA. By knowing that, we can use proportion. So this is 9 and this is 5 from the small triangle. What is the length of AC for the big triangle? A to C. All together, 9 and 3 together, 12. What is X? That is the question, okay? So let's set it up, the equation, which is the proportion with the ratio. 9 over 5 or 5 over 9. You can set up 4 different ways of the equation to get the same answer, okay? So you go higher number and lower number, and next to triangle, higher one or same part, corresponding part first, and then make an equality. So this is the equation we need to solve. How do we solve? Cross multiply. So let's cross multiply, okay? So what do we get? 9x equals to 12 times 5, right? So what is next step? Divide everything by 9. So let's get rid of common factors. 3 times 3, 3 times 4, right? Yep. So answer will be 20 over 3. It's not an integer, right? But that's okay. We can have fraction as an answer in math class. So that is the final answer. Next one, example number 4. Given 3 times of UT is same as 5 times of RT, and 3 times of VT is same as 5 times of ST. Prove two triangles are similar. What is the meaning of this? What number do you see from here? 3 and 5, right? 3 and 5. So let's think about this, okay? Which is longer than 3 times of something and 5 times of something? They are equal to each other. So think about number line, okay, or number balance scale. You have 3 over this, and you have 5 over this. I put circle and star, okay, here. This is star. Which is heavier?
Uh,
One star or one circle?
One circle.
Yeah, one circle is heavier, right? Because, is it?
There's more stars in circles.
Yeah, more stars. So
They equal
if
the
the total is the same, that is makes sense, right? So we think about kind of a number sense here, and we recognize same numbers from 3 and 5, 3 and 5. Okay? What is the meaning of that? So let's think about 3 and 5, 3 and 5. So what is the ratio on this? So from the first reason to second statement, so let's think about writing this. What is going to be the reason for the first statement? We saw it, right? What is it called? Given, that's right. And I see another given in number 3. So what do I need to put in number 3? The other one, that's right. So we saw that, and then that is called given information. From number 1, I need to conclude number 2. From number 3, I need to go number 4. So we recognize same numbers here, and I'd like to go with 5/3 or 3/5. Either way, fine, okay? But I'd like to use the same number. What is the meaning of a same number from both equations here? That is the same ratio, so we can think about dilation. In other words, two shapes are similar to each other because we have the same proportionality. Does it make sense? So we got the same number. We need to get the same number. What happened here? What did we do to get number 1 to number 2? Divide both sides by 3 and divide both sides by RT at the same time. Okay? Divide both sides by 3 and then you get UT equals to 5RT over 3, right? And then divide both sides by RT to get rid of this. And then we have a number itself. Make sense? What's the meaning of this? Two lengths are in certain ratio. That's the meaning. Okay? This one divided by this. That means top one is longer, bottom one is shorter. Got it? That's the meaning. So we see the common numbers in the equation we can manipulate, and then we can get a number. And we want to compare that number just like above. We did division, we got the quotient. Quotient's the same. So what is the reasoning to get 5/3? Division, property of equality. We divide both sides by RT and at the same time divide by 3. Okay? Next one, we do the same way. Division property of equality. And then we end up with this. And we have one more information from this drawing. What is the common information from this? By using vertical angles theorem, we can name these two angles are congruent to each other. So let's name it, okay? So which part do we start first? Let's see the question. UVT, big one first, okay? So let's name this part first. UVT, can I use that? Yeah, angle UTV, right? UTV, that's right. Is congruent to angle which is corresponding to U. S, that's right. U is the first letter, right? U, BT, and then R. Oh, yeah, I will change that to later. It should be S, RT, right? It doesn't matter, but yeah. So let's go with angle STR. They are congruent to each other. Now we have two lengths has same proportion and one angle is congruent. So we can conclude that triangle UTV or UVT is congruent to triangle SRT or RST. That's fine. SRT. So they are congruent to each other. What is the reasoning? Slide. Angle, side, triangle, similarity postulate, okay? Similarity postulate to prove similarity. Yes?
Number 3, is that 3 UT or 3?
Right, now let's look at example number 5. The photo shows a gable roof and typo here. Segment AC is parallel to segment FG. AC and FG, they are parallel. So what kind of a triangle do you see here? It look like equilateral triangle? No, it doesn't look. Is it this isosceles triangle? It looks like it, otherwise the symmetry doesn't exist here, right? But I'm not sure it's isosceles here because it's not given like that, okay? All right, what could be the other one here? That is trapezoid. Must be same legs, so it look like isosceles trapezoid, but we cannot guarantee they are equal to each other from this image, okay? Because it's not notated or given. So let's use just two lines are parallel. If we have parallel lines, angle A is congruent to angle F. Why? Because they are corresponding angles, okay? Same location angles from two parallel lines and transversal, we have corresponding angles. Like this, angle C is congruent to angle G. Why? Because they are corresponding angles again, okay? And do we have any hidden clue from two triangles? ABC is the big one, and then FBG is the top one, small one. Angle B is common from both triangles, right? So angle B is congruent to itself, reflexive property. Okay, so angle B is congruent to itself. Angle A is congruent to angle F. Angle C is congruent to angle G from corresponding angles. So what is the reasoning to say two triangles are similar to each other? Angle, angle. We confirm all three angles are congruent to each other, but we can just say angle, angle, triangle, not congruence, similarity postulate, and we can conclude that two triangles are similar. When you have similar triangles, all lengths are proportional, okay? So we have big one and small one. So what is the question? Find BA. Where is B? Where is A? The whole thing, right? So that is the question. What is this? So let's take the ratio. What is the ratio between big triangle and small triangle? So I can use the base of that triangle, and then we can calculate, right? So this is AB. What measurement do we know? This is 17, right? Is this for BA or is this for AF? If that is BA, that's not going to be the question, right? So that is for AF. So we have AF 17. AF 17. So what would be the PF then? Can I find PF first? And then we can find AB. Yep, that would be the easier way. So let's find the length of BF, and then let's find the length of AB after that, okay? So I'm going to set it up, this BF as X, okay? If I set it up this as X, what would be the length of AB? X and 17 together, right? X and 17 together. So use the unknown part to find your answer. So this is PF, which is unknown, so I put it as X. But when I answer the question, I will answer BA, which is AB whole length, okay? So I will add 17 on the X value. So let's set it up, the equation. So 24 and 6.5 goes as X plus 17 and X. Big one, small one, big one, small one, right? Corresponding parts together. There are 4 different ways to set up an equation, but we'll get the same answer, okay? So match the part, corresponding parts, and big number, small number, like that, okay? Right, so let's solve it. Let me erase this. I did some warm-up with the students, and I have some work here. Let me erase that so I can use the space. Okay, how do we find x value? What do I need to do? Cross multiplication, right? So 24 times x equals to 6.5 times x plus 17. So let's expand. 17 times 6.5, what do we get? 110.5. Okay, now let's move the term. So 24 subtract 6.5, so that is 17.5x, which will be 110.5. Last step, let's divide. When you divide, answer is approximately equal to 6.314. It's not a fraction. It is kind of a real life situation problem, right? And then decimal would be fine. What is the unit for this answer? Remember to put the unit in real life problems. That's right, it is feet. Is that my final answer? No, it's not my final answer. It is the unknown for BF, okay? So we found BF, so this is BF. BF is about 6.314 feet. So what is the question? Find the length of BA. BA can be written as BF plus 17, right? So let's add 17 on it, and then we can have whole length. So 23.314 feet. So this is going to be the answer.